This is AddMaths exercise 4B question 9. A bag contains 12 red and 8 blue balls. 12 red and 8 blue balls that are identical except for their colour. A ball is chosen from the bag, its colour is noted, and then it is replaced. 8 balls are chosen. And in part A, we've got to find the probability of obtaining 5 red balls. This is a binomial probability question. And in binomial probabilities, we always need two things to start with, n and p. We use a shorthand, b by binomial and then the n and the p. The n is the number of times we're doing something. And here we're choosing a ball 8 times. So in this question, n is 8. The p is the probability of success, the probability of getting what we want. We want a red ball. Well, the probability of getting a red ball is 12 out of 20. There are 12 reds out of 20 balls altogether. That will cancel down to be 6/10 or 0.6. And the question did say the balls were replaced. So that never changes. As one ball comes out, it goes straight back in again. So we've got our n and our p. And for part A, the probability of obtaining 5 red balls, that will be our little r number. R is 5. That's our requirement. We require 5. To answer any of these questions, you always need to learn to memorize the formula. It's not given to you on the AddMaths paper. The binomial probability formula is n choose r, p to the r, 1 minus p to the n minus r. Now in this question, we've got our n, it's 8. We've got our r, it's 5. We've got our p, it's 0.6. So it's just a case now of substituting those in. So the probability of getting exactly 5 reds will be n choose r, p to the r, 1 minus p to the n minus r. So we've got 8 choose 5 times by 0.6 to the power of 5 times by 0.4 to the power of 3. If you do that on your calculator, you get 0.2787. Part B of the question is asking us for the probability of obtaining at least 2 blue balls. At least greater than or equal to 2 blue. Well, let's just go and look at our n and our p again. We're still choosing 8 balls. So n is still going to be 8. P, the probability of getting what we want. Well, this time we want blue balls. Now there are 8 blue balls altogether out of 20. So P will be changing this time to 8 out of 20, which is 4 out of 10, which is 0.4. And we want at least 2. And at least 2 means 2 or 3 or 4 or 5 or 6 or 7. So we could find the probability using this formula we use here. For 2, we could get that answer. For 3, we could get that answer. For 4, we could get that answer. And for 5 and 6 and 7 and 8. And it would take an awful long time to finish. So there's another way of looking at this. If I want the number of blues to be greater than or equal to 2, that's a probability. The probability of blues is greater than or equal to 2. That's exactly the opposite of the blues being strictly less than 2. So these are opposite things. Greater than or equal to 2 is 2, 3, 4, 5, 6, 7, 8. The exact opposite is less than 2, which is 0 or 1. And because it's an opposite, we do 1 minus. Because all probability adds up to 1, if the opposite thing always has a probability of 1 minus the other thing. So I can switch this around. We're doing 1 minus the opposite. The probability of getting less than 2 blues, I need to work out the probability of getting 0 blues, b equals 0. And I also need the probability of getting 1 blue, b equals 1. That or that will do, and for an or, I will add. So, then, once I've done that, remember I still need to take that away from 1. So I'll put that in here at the moment. It's 1 take away those two probabilities added together. So, using the formula we had earlier, which was n choose r, p to the r, 1 minus p to the n minus r, I'll work these out. First of all, the probability of getting no blue balls will be n choose 0, p to the power of 0, 1 minus p to the power of 8 minus 0. So that's the probability b is 0. B is 1, follows the same pattern, but it will be 8 choose 1, 0.4 to the power of 1, 0.6 to the power of 7. And I need to add those together and take that away from 1. If you work this out, the first answer you get is 0.0168. The second probability is 0.0896. If you add those together and subtract them from 1, you get a final answer of 0.8936. And that's the answer to part B of that question. Part C is asking for the probability of an equal number of red and blue. So, bearing in mind we're taking 8 balls out, an equal number is 4 of each. So I need B to be 4. So I want the probability that B is 4. From before, we knew that N is 8, and our probability of success, if we're dealing with blue balls, is 0.4. This is our R number, the number you require, and the formula we've been using is N choose R, P to the R, 1 minus P to the N minus R. So, we substitute in, it will be N choose R, P to the R, 1 minus P to the N minus R. And if we work that out, put that into a calculator, you get an answer of 0.2322. That's the answer for part C. The final part of the question is trickier. It says how many balls need to be chosen if the probability of obtaining at least one red ball is to be at least 99%. Let's just try and write something down. It says how many balls need to be chosen if the probability of obtaining at least one red ball, so red is greater than or equal to 1, that probability is at least greater than or equal to 99%, so 0.99. Now, when you have at least one, which is 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8, in this example we're stopping at 8 at the moment, we need to work it out the other way round. It's far easier. If you think of the opposite to greater than or equal to 1, the opposite of greater than or equal to 1 is less than 1. And if the probability of greater than or equal to 1 has to be 99% or more, the probability of less than 1 has to be 0.01 or 1% or less. So we switch the question round. And it's easier because here, instead of doing 1 or 2 or 3 or 4 and so on, r less than 1, well, there's only one thing that r can be less than 1, and that's r is 0. So what we have now is this. Instead of lots of possibilities, we're just looking at one value. We want to know what's the probability of getting no successes. Sorry, we want to know the number of choices we've got to make to have no successes less than 1%. So let's have a look at this probability here. We're dealing with this question with an unknown sample size. We don't know what n is, but we do know that p, the probability of success for a red ball, is 0. Let me just check earlier on. For a red ball is 0.6. And we know our answer has to be smaller than that, and we know also in this one that our R number, our required number, is 0. So the formula we've been using before is n choose R, p to the R, 1 minus p to the n minus R. This will be continued in a new file.